Post your topic, books and brain dates. Learn something new. This session will be available for on-demand viewing after the session concludes. Presentation slides and other supporting documentation the presenters would like to share with you are available for download on this page. Thank you for listening. Enjoy this session and have a great GTC.
This presentation is about a story of how we succeeded in making AI accessible from anywhere to students, faculty, and researchers at the University of Pisa during the pandemic. During the COVID-19 pandemic, the big challenge for our university was to find solutions. We're able to add flexible computing resources for conducting research remotely. This was due to the fact that we were unable to access anymore our bare metal facilities, and so we have to think about designing new solutions for making everything accessible from remote. On the research side, the increasing demand that we have for AI, deep learning, and machine learning application support the complete redesign of the computing infrastructure to integrate virtualized resources that we have on vSphere and other infrastructure together with AI Enterprise in order to integrate them with bare metal facilities, late storage, and network technologies. What we will try to go through in the next slides is how we go through the infrastructure, the decision that we take about how to mix the composable, flexible, and high-performance infrastructure. The idea that was at the base of our installation was a flexible infrastructure. Design a flexible infrastructure. So, first of all, we decided to use the infrastructure as a whiteboard to design IT solutions, integrating the bare metal and the virtual board together. Then we decided to maximize the flexibility that we have on the virtual infrastructure. Of course, this, especially in the design phase, we think about on how much performance we have to sacrifice for the sake of flexibility. And at the end of the day, we decided to go for virtualization, even if at the time we thought about losing some performance. And then at the end, we decided to exploit the power of the virtual desktop and workstation that were running on our infrastructure. So let's go into details of our bare metal infrastructure was made for AI and HPC. We started from a traditional HPC infrastructure that is at University of Pisa is available from several years. And with the request for AI infrastructure that came out in the latest years, we integrate a lot of AI bare metal solutions. So we started with NVIDIA DGX clusters to arrive to the final installation that we have now, that are DGX A100 cluster. And we mixed with other solutions like Dell Technologies XE platform with NVIDIA A100, together with some other gears from Dell Technologies like all the R740XD, all equipped with NVIDIA cards, several versions, several generations, several offerings that we have for our internal customers, mixed with the latest bits of technologies either on the networking and storage side. So, for example, we moved to the latest available Bluefield cards from NVIDIA, mixed with InfiniBand cards. We go through the adoption of NVIDIA switches, either for the 100 gigabits Ethernet and InfiniBand networks. And we use all this infrastructure to deploy next generation storage solutions like Dell Technologies PowerStore X, together with the all-flash arrays that were coming on the market. For example, partners from our university, DDN, with the AI 400X, and the Accelero, with the NVMesh storage arrays that were deployed on this infrastructure with a lot of success. From the platform's point of view, what we adopted was a mix of open source and proprietary solutions for software, trying to mix everything together. So at the end of the day, on the platform side, we have a mix of software for managing bare metal infrastructure, a software for managing virtual infrastructure, and software for managing either of them to integrate the AI infrastructure at its best. So if we start from bare metal NVIDIA platform, the main platform is DGX OS, integrated with the scripts from NVIDIA, from the DPOPs, that help us in configuration of the cluster, on configuration and partitioning of the systems. Of course, in mixed with the software stack, always from NVIDIA, either for HPC and AI and the NGC containers that give us a lot of flexibility in using AI application containerized and downloaded from the cloud. On the same time, we have vSphere platform from VMware, mixed between SXI offering and Horizon offering. So virtual platform and virtual desktop platform mixed together to offer, together with NVIDIA software, the possibility of virtualizing a remote workstation, and together with the possibility of auto-deploying virtual machines for AI. And mixed, of course, with some other technologies. For example, the Omnia software from Dell Technologies that we use to virtualize HPC infrastructure on top of VMware, or the VHPC scripts from VMware that we use from design virtual infrastructure in the virtual world, where we can put over all the HPC virtualized offering. And this, of course, included open source Ubuntu distribution and OpenHPC as a platform to do the same work that it did in bare metal on the virtual world. For example, we can add the BGFS parallel file system on top of VMware to work together with the traditional bare metal BGFS parallel file system. At the end of the offering, the latest come was NVIDIA AI Enterprise software that completed the offering to offer AI infrastructure on top of the virtual world. If we give a look of what virtual infrastructure was for us for HPC, these are the components that we use in the design of the solution. So you can see the integration of NVIDIA hardware components like the networking and the RDMA interconnect, together with the technologies from VMware, like SXI, as you can see, or vCenter, that we use to manage all the infrastructure, and the design on top of this infrastructure of all the solutions were needed for HPC, like, for example, NFS file system or parallel file system that were needed to offer the traditional HPC storage. And of course, we integrate all this infrastructure with the AI-ready enterprise platform from NVIDIA. And you can see the base of the installation was almost the same with the virtual HPC offering, integrating last offering from NVIDIA, like the SmartNIC DPUs that we have in our infrastructure, together with NVIDIA GPUs. And of course, the balancing of virtual world and Kubernetes give us a lot of flexibility in operating our HPC and AI infrastructure. So at the end of the day, what we give to our researchers was the possibility of accessing and designing from everywhere a flexible solution to integrate HPC at first and AI at the end, using the framework from NVIDIA and like AI Enterprise, because NVIDIA Enterprise give us the flexibility of doing infrastructure optimization, integrating AI and data science tools together, and to deploy cloud-native infrastructure. And last but not least, all the features that NVIDIA AI Enterprise brought us in production systems. So when we move from the bare metal system through the virtual offering, now we can with NVIDIA AI Enterprise provide to our researchers all the AI frameworks, which typically needs a lot of time to install and configure and optimize. So at the end of the day, what we succeed in having was a very flexible infrastructure, very optimized, with the possibility for our researcher to have the best of either worlds, HPC and AI, available on the same virtual platform. So everything at the end was available from remote. Every piece of infrastructure can be managed and designed remotely on demand, either for the system manager, but also for the users. So the users can design virtual classroom, but that can be deployed on demand, either normal virtual desktops or with GPU support. Users have available visualization portal like Jupyter Hub or Open on Demand to use the system as flexible as possible, and with the possibility of design a very useful workflow and way of working. But at the end of the day, as we can see from a quote from one of our professor, what we achieve was the fact that we didn't lose performance in a significant way on using AI applications on top of the virtual world. So at the end of the day, the performance of our internal developed AI workloads were almost the same, either on the bare metal or on the virtual platform. So at the end of the day, what we achieved was the possibility of having an infrastructure that was integrated with bare metal and virtual solutions, with almost the same performance for the AI workload, with the flexibility that we needed to put all in production, either on site or remotely for our users. And of course, we are not stopping here, because we are still developing the platform. And we foresee a composable infrastructure, because the idea is to bring the flexibility that we have achieved on the virtual world also to the hardware level, and try to integrate better than we are being able today to integrate virtual and bare metal world. And of course, we are always open to test, to deploy new solutions, like, for example, Project Monterey, that is near to come for our future.